All right, hello everyone. Here we go. Okay, I'm going to give you kind of a quick version of a talk I've been doing at conferences that's been kind of fun. It's called the End of the Data Ice Age. My name is Hugh Mckee. I work for Lightbend, company behind Scala, Akka, all that cool stuff. But we got something else that's pretty cool that's really kind of changed the way I look at how we do development in a pretty profound way. And I'm kind of jumping ahead in this presentation, but I did this, I like doing my slides using Blender. Anybody know about Blender? It's an open source 3D tool. It's marvelous. It's just, people do movie animations with it. I'm a pure amateur with it, but I see tutorials and I can do cool pictures like this that can kind of get a point across. I like doing it, so it's fun. Anyways, I've been working on something new that's a highly abstracted way of doing back-end application development. And it got me thinking that, you know, why is it in the third decade of the 21st century are we still doing computing that's really dictated by the kind of hardware that we use? And in particular, it's that, you know, we have the ability to compute, but we also have to deal with the fact that we have to use persistence. And this is what really started to get me. Yeah, I'm an optimist, you know, I'm old, I've been doing this for a long time, and I always like trying new stuff. And I always look forward to new stuff. But it's like, come on, man, you know, it's like, I was sitting there thinking, it's the third decade, the 21st century. I was really looking forward to this decade until it all went to hell. But you know, it's like, why are we still doing something that I've been fundamentally doing for decades as far as application development? And it's really the fact that we have to deal so much with retrieving data from persistence, the persistence layer, doing our computations on it and putting it back in there. There's a lot of effort, you know, to do that. Not only mental effort to do it on ourselves, you know, to write the code to do it, but it's also effort on the, you know, the underlying infrastructure. So this abstraction layer, another cool tutorial from Blender, is, in my head I was starting to see this concept of this abstraction layer that I've been using eliminates the whole part of the persistence piece and a lot of other things. But it was this elimination of persistence made me think of doing this talk where I was thinking the end of the data ice age. And because what I mean by data ice age is that when you put data into storage, it's putting into cold storage. The data is frozen. You don't change data in the database. You got to get the data out of the database. You got to get it into a hot state, run your code against it, make some kind of change, and then push it back down into the persistence layer. So this kind of mental picture that I had in mind when I saw this tutorial, this Blender tutorial, I said, oh man, this is the picture I want to use, is that I think of the data as just kind of these hot objects. That's what these little spheres are. So that's what I want to show you here. And I just want to start with this abstraction layer that I'm using has some really simple, fundamental building blocks. And there's only 3. And I'm doing stuff with it that's like what I've done before with Akka and all these other things. And so it's been kind of blowing my mind. But so one of the components here is called an entity. And you can think of an entity as having an API. You know, it's a way of communicating with this entity. And the entity is composed of code and state. So the idea is that you do your computations here. The data's there, the code's there, and commands come into these entities to perform operations. You know, like, so I'm going to show you like a shopping cart order processing example in a little bit. So say a command is add an item to a shopping cart, okay? Or change an item, remove an item, things like that. And then what happens is that when state changes occur, the state then is admitted out to some kind of a state store. But the fact that the state is in some persistence layer is abstracted away from us as developers. So that's why I want to show you some code. So here's some Scala code that's implementing what's called a value entity, which is it's got state, and you can see this one's a simple one. I'm going to show you a shopping cart one in a minute. That here's where this create order is a command. And you can see that there's a create order command that comes in, but also you can see that the state is passed in as well. So this code that we write to implement these things has no database connection, has no concept of dealing with transactions. These things are scalable, they're durable, they recover from failures. All those kinds of things are not our concern. What our concern here is that we've got a command coming in, along with the command is the current state of the thing, like the instance of a shopping cart, or in this case, the instance of an order that's being manipulated. We process this command, and the code here is my style. I mean, I had to implement this method, but I like using this handle method. And what you can see is that what I have to do is I have to return the altered state. So there's this effect dot update state, and then I reply with which is called an empty. It's like an acknowledgement. Yep, I got the command, I processed it, it's good. So like I said, there's no database connection here. So the state's injected into the entity when a command is sent to it. The data that's associated with that command, you run whatever kind of business logic to process that command. You alter the state of the entity, and then you turn the state back to the abstraction layer. And the abstraction layer, of course, persisted. Okay, but the point here is what you don't have to do. Like I say, there's no database connections, there's no transactions, there's no retrieval. Still dealing with data. I had to define my state, I had to define these commands and things like that. But the drama associated with much of the coding is significantly reduced here. In addition to things like, this is not a stateless system, this is a stateful system. But the abstraction layer is handling the state. So say when let me move on, I'll show you the shopping cart because that's more interesting. This is another entity type. It's called an event source entity. So how many people are familiar with event sourcing? Fair amount? Okay, so event sourcing is the concept of, instead of getting the state and performing some type of operation and you change the state, like you add an item to a shopping cart, so you're updating the shopping cart object, say. The idea is that you're emitting events. So instead of updating the object itself, you're saying, all right, I'm emitting an event called add item, and then in another event called add item, and then I'm in an event remove item, and then an event change item, and then an event checkout. Those kinds of things. So it's the aggregation of all those events that lead up to the current state of the entity. This is really good though for kind of streaming types of operations, because the semantic content going downstream is much more meaningful. When you see, if I did a shopping cart with this value entity approach, and you change the shopping cart, what comes out the other end is, yeah, the state was changed, but it's kind of ambiguous. What changed? With an event source type of an approach, it's very clear, because you're emitting an event. I added an item. So going downstream, because we're processing or consuming that event, the semantic content is there. So it's an add item, change item, remove item, checkout, all those things are much more meaningful. So here's an event sourcing example. This is the shopping cart. Very similar though, you can see, here's the add item. And again, the state's passed in, and the state is also coming in with command. So what I meant about the state, this is a stateful system. Say the shopping cart had already become active. Say you're shopping, you're hitting this application, and you're adding, you're playing with the shopping cart. You're adding items, you're removing items, you're kind of you're buying, right? Well, the abstraction layer is keeping the state in memory because it's active. Now, the fact that this is happening is, again, not a concern. It's a feature, it's kind of a curiosity to know that there's some optimization that's happening within the abstraction layer, but we as developers don't have to deal with it. It's just kind of nice to know. So it's the same type of a flow though. The difference is though that some people, I don't know, I've just been playing around with my coding style here a little bit just for fun, but I'm using this line to do validation, like reject, it takes the command, it looks at the state in the command, and it validates, is this command possible to be processed given the current state of the thing. Like, say if the shopping cart is checked out, you try to add an item, it's going to reject it. That's all I'm doing here. And it's an option. If it's not rejected, then it's just going to go on and perform, it's going to handle the command. So I'm just going to jump to the handle, save some time. So the last example I showed you, it was updating the state. Here, it's emitting an event. So what this method that I wrote, and again, this is my style, you don't have to do it this way, is I just wrote a method called event4. And the event4 just creates the event given the current command and the current state. And then there's another thing that has to be implemented here, sorry for the scrolling. There's command handlers, methods that you have to implement for the commands, but there's also methods that the event is emitted, it's persisted by the abstraction layer, and then once it's safely persisted, then there's another method invoked that takes the event and alters the state. So let's see, there's a item added, for example. And here in the update state, I'm fed back that event. So it's kind of a multi-step process. The command comes in, you process it, you emit an event that gets persisted. When it gets safely persisted, then the abstraction layer calls your code again to say, all right, now change your state. So like add the item to the cart. Basically, that's it. So that's an event. That's this event sourcing. Again, no database setup. The journal, snapshotting, all these things that are associated with event sourcing are handled by the abstraction layer, and we just focus on the code. Now, next part is with event sourcing, there's what's called CQRS, Command Query Responsibility Segregation. And what that means is that commands and queries are separated, so down to the data level, where how the events are stored, events go into some kind of event journal. That's not a very queryable data structure. So with event sourcing, and this is general event sourcing, it's not something that we invented at Lightbend or anything. You store the data in the queryable views. So queryable views are set up in the same way in that as events are being written to the journal, there's code that picks up those events and then updates views. But it happens not within the same transaction. So there's kind of an eventual consistency, latency between when events actually get captured by the system and when that data is visible in the views. So this gives people pause, especially because I always say we're hooked on ACID, the atomic transactions, and this is kind of breaking that habit. From my own recent experience, it's not as bad as I feared. The stuff that I've worked on so far, typically not having those ACID type of transactions, atomic types of transactions all the time, is workable. So a CQRS example, let me just show you some code. I'll go back there. All that's really happening here is that when these events are handled by entities, then you define views that have transformation methods that take in the raw entities and updates the view data. So this is basically what's happening here. So the thing I want to point out here is that these, again, there's no database. The retrieval of the events from the event journal is being handled by the abstraction layer, so there's no code like pulling the events in. This is kind of a dependency injection kind of a thing, a data injection kind of thing. The data is injected into your code, Your code responds to it, does what it needs to do, and lets the abstraction layer take care of everything else. So it's a major simplification of the coding effort here. And the inputs, of course, into these entities, it's an API, so the API can be publicly accessible. But another common flow, and this is where things really start to get interesting, is that you're starting to build junctions in, say, consuming from a topic, performing operations on those messages in the topic, and then pushing things out to an event journal. You can think of event journals as a topic as well. And I'll kind of build on that as we go through here. So here, for example, there's a shopping cart entity, and then there's an order entity. And what happens is that the shopping carts are getting built up, and often the shopping carts get abandoned, that an order doesn't happen. So they're uninteresting. They might be interesting from a data analytics standpoint, but they're not interesting from, we don't have an order. But when a shopping cart is checked out, that's when things get interesting. The system itself has to respond to that. We need to fulfill that order. So what's happening here is that there's this second component here. I said there's three components. There's entities, there's views, and then there's actions. So this little A thing up here is called an action. An action is a stateless function. So you write an action that consumes events from an upstream component, and it can filter and act on specific events. So in this case, what this action is looking for is a checkout event. So when a checkout occurs, that will trigger sending a command to a downstream entity to say, all right, we need to create an order because we have to process this order. So you're kind of stringing things together here. The term I've been kind of playing with is, it's a stream, but it's like microstreams, because these entities I kind of think of as microservices, really focused, small, tight microservices, the way microservices actually is supposed to be. And, but they're being orchestrated together in these flows. So a flow of events coming out of shopping carts flows into orders, and then I'll show you the full system here in just a minute. But the point I want to make is that these entities, which are the kind of where the main business logic is, that think of them as durable objects. So say if you have hundreds or thousands of people actively shopping like right now, in the system, in memory, there's hundreds or thousands of these instances of shopping cart objects, durable objects, or order objects. And when commands come in to say add an item to your shopping cart or add an item to my shopping cart, the abstraction layer is handling the routing of each of those specific messages to that instance of your durable object, regardless of where it is in a cluster of machines. So when the system scales up, of course it's scaling up on many, in this case, underlying Kubernetes pods, which are effectively running JVMs, running out of VMs somewhere, that type of thing. So you could have objects distributed all across a cluster, but the routing of each specific request is being routed to each specific object. This is what Akka does. So this abstraction layer is built on Akka. And so this is where it's a hot state system, that all those entities are currently active, they're currently receiving commands. The abstraction layer is keeping them in memory as much as possible so that we don't have to keep going back to the database like in a stateless systems and constantly retrieving state on every single operation. Which gets us into microstreams. So this is the full, this is a demo application. I'm working on a Scala version, not the code I've been showing you is the Scala version, so it's in GitHub. Just change Java there to Scala, and you'll get the current project. I'm hoping to have it completely working and done, the Scala version, in the next week or so. The Java version is already done and working. But this application is built using these three components. So the circles are either value entities or event source entities. Those little triangles, like at the top of the shopping cart, those little triangles are views. And so that the shopping cart has three different queryable views on it. And then the arrows are, you can think of those as topics, and the arrowhead is an action consuming the messages, the things that are being put into topics to go downstream to another component. So I'll walk you through what happens in this system, because this is kind of a cascading sequence of event application. So when a shopping cart entity is checked out, as I'm highlighting here, it emits an event which is picked up by order. The order consumes that event as a command which triggers it to create an order. When an order is created, it cascades and it goes, its creation event is picked up by two other entities. One is an order item, which is kind of there just to show a reporting type of a thing, but the more interesting one is the flow continues, the flow cascades into the shopping cart entity. I'm sorry, the shipping order entity. The shipping order entity kind of explodes the order out into another level of detail, because what happens is when a shipping order is created, it emits an event which explodes out to what I call the order SKU items. So for example, say you had a shopping cart with two items in it. One item had a quantity of 1, the second item had a quantity of 2. That would result in creating 3 order SKU items. So there's one object, in the shipping order, there's 3 individual, because what the system has to do is find stock for each physical item that's in the order. So that's what's happening here. The really interesting part, though, happens when these order SKU items are created. So when order SKU items are created, then emits an event, which is picked up by a stock SKU item. So what we're trying to do here is non-transactionally come to a mutually agreeable series of state changes between the order items and stock SKU items. So what happens here is it hunts for available stock SKU items that can be joined with order SKU items. Typically, what we would normally do when we're hooked on ACID is we do a single transaction to make all this happen. In this case, there's no transaction, but what's happening is there's kind of a saga, like exchange going on back and forth here. Events are being emitted by the stock SKU items, happening concurrently as well, by the way, because all these things, there's 3 stock SKU items for this order created, so they kind of all concurrently go looking for stock. So they go to the stock SKU item, so it's a much lower level of granularity. But the effect here is a little different. You can see that little arc on the stock SKU item. What's happening there is the action, what it's doing is it's doing a query to find an available stock SKU item that hasn't been allocated to an order, so that it can build the command to be sent to that specific stock SKU item. But basically, the stock SKU item is sent this command. So this is the flow here between the order SKU item and the stock SKU item. Remember I said the event journal, think of it as a topic. As those events are getting created in the stock SKU items event journal, those events are being picked up by the action at the top. It does a query against the view of the stock SKU item, looking for an available stock SKU item. If there are some available, what it'll do is it will send a command to that stock SKU item and say, hey, I want to join. If there isn't available stock, the action sends a command back to the order SKU item and say, hey, put yourself in a back order state because we have insufficient stock. So that's happening in an action, which is right here. Pretty straightforward again. The event is injected into my action code. I don't have to retrieve it from the journal, anything like that. And doing a query is a query is another service with APIs. So you can see components, which is part of the abstraction layer, stock SKU items available view. I want to get available stock SKU items, so I retrieve it, and then that returns a future, which gets flat mapped into the next stage, which is, let's see if there are any available stock SKU items. If the response is empty, I'll do a back order, which just sends a command to the entity to do a back order. If there is stock, then I'll randomly select one of the query result and then send that command into the stock SKU item. That's kind of it. Again, it's just kind of basic code. focused on what this thing's supposed to do, not everything else. So in a stock SKU item, if it's allocated, which it may not, it could be that, you look at a view, the view is behind. The view could think that a particular stock SKU item is available, but when you actually go to that entity and send it a command, that entity may have already been allocated. So the stock SKU item may or may not accept the command. If it accepts the command, it emits an event that says, yep, everything's good, we're joining. If it doesn't accept the command, it will emit another event that says, no, I reject this request. In either case, now the flow kind of goes in reverse. The stock SKU item emits an event that the order SKU item picks up. And the order SKU item is either going to be, yep, everything's cool, or no, I need to do a retry. I need to just repeat the process and try an available stock SKU item. Also, events are emitted to the stock order. It's just to kind of show, deallocating stock. Then, as changes occur to the order SKU items, it updates the shipping order. When the shipping order updates, it finally emits events to pick up change the order state. What kind of happens here is you hit the checkout button, and it starts a whole cascading sequence of events that kind of ripple through all these different entities and kind of flow out and then flow back. But it's all our design. So the fun part of this kind of a system is designing these kinds of flows. The messaging here is guaranteed at least once delivery. So like you guys were saying earlier, you have to deal with duplicates. So in some cases, you have to consider item potency. But exactly once is kind of it's possible in very small, special cases. We'd love to have exactly once messaging, but speed of light's too slow, time, damn Einstein, we just screwed us all up for this kind of stuff. So it's like exactly once is forget. But at least once is kind of the norm. But the cost is you have to deal with item potency. So like when I write all the unit tests for this stuff, I'm always adding like an item potency test. Like get an entity into a certain state, and send the same command to it again, and examine the state to make sure that entity didn't change. But it's actually kind of fun to do because it's like, oh yeah, cool, my code's working. But the really fun part for this, and this was really eye-opening for me, was doing these kind of asynchronous cascading flows. And these kind of stream, like I call it, microstream types of flows. And I had to work on the actual messaging flow between the order SKU item and the stock SKU item. That was the most complicated part. But there was so much that I had to unlearn. I kept approaching the problem like, well, I could just do this get, or I could, and it's like, no. You got to think of this as like just asynchronous events being picked up. This thing does something. It doesn't care who's consuming those events. Like the order SKU item. Each one of these entities, in the order SKU item, for example, each one of these works kind of independently and blissfully ignorant of the rest of the system. So your order SKU item, you design this flow, but then you kind of design and implement each entity very independently. And so you know exactly what commands are coming in, you know exactly what events are coming out, but you don't really know who made those commands or who's consuming those events. You don't really care. So another one, this one got really fun, and I'll wrap up here. This was a proof of concept for a customer that we're working with, and their problem was that they have a massive topic that tens of thousands of transactions are flowing into. And they needed to aggregate all these transactions into what they call merchant payments. And the problem was like, well, how do we solve this problem? Because what the merchants wanted was to periodically get payments. It's like maybe once a day, maybe once every 8 hours. Every merchant was different. But we got tens of thousands of messages per second flowing into the system. And the design we came up with here was really kind of interesting. So what's happening is that each one of these circles, again, is an entity. Each arrow is the event journal. The arrowheads are actions, so these are real components in the system. So when a transaction is created, that emits an event that goes to a sub-second. So a sub-second is like a 10 millisecond window, so for a given merchant. So it's accumulating transactions in a small period of time just for a particular merchant. So the data starts to fan out very, very quickly. So you can imagine there's hundreds and maybe thousands of sub-second entities, one for each merchant for each 10 millisecond window. But then these things start to bubble up. So whenever a sub-second is what I call activated, meaning that it's got a live unaggregated transaction in it, it's active, it emits an event that goes up to the next unit of time, which is the second. And the second is the time window is bigger. So what it's just keeping track of is what sub-seconds have data that needs to be aggregated in there. It's just keeping a list, right, internally. And it just bubbles up, to minute, hour, day, and then it ultimately a message is received by a merchant, the merchant. And what the merchant does is it turns around and emits an event that says, all right, I know I've got some unaggregated data, so I'm just going to send back a command to start an aggregation. So it emits an event that goes back to day to say, hey, day, aggregate what you got so far. And day goes to hour, minute, second, sub-second. When sub-second gets that message, what it does is it sums up its currently unaggregated transactions. And it does some bookkeeping there, and it emits an event going back up down the tree again to its second to say, all right, here's the aggregated data for this sub-second. So all the sub-seconds within a current second all get these commands. They do their aggregations, and when the seconds receive all the incoming messages from the currently active sub-seconds, then it goes, okay, I got all my data. I'm going to sum it up and then push it up to a minute, an hour, a day, and then it goes to a payment. So what's happening is that what the system's doing all day long is this kind of boom or pendulum swing. Data's flowing into the system, and it kind of slowly bubbles up to a merchant to say, hey, you've got some data to aggregate. The merchant goes, all right, go ahead and aggregate what you got. So it kind of flows back out to, this is like a big, huge tree. The payment and merchant are at the trunk, and the transactions are like the leaves of this huge tree. So just constantly harvesting on the unaggregated data back and forth. And then whenever it's time to do a payment, we just grab the current value. So instead of like triggering some kind of massive batch operation or something like that, or some kind of heavy computation when we want to do a payment, what this system's doing all the time is just kind of aggregate. Now, the cool thing was, when I was working on this design, I had the flow kind of going without the boomerang, going back and forth. And we were thinking like, okay, well, how do we trigger an aggregation? Another feature that's going to be added to this is timers. It's a new feature that isn't there yet. But in any case, thought, well, yeah, periodically we'll do a timer that will trigger an aggregation. But then all of a sudden it dawned on me, so wait a minute, I don't need a timer. As soon as a merchant knows that it's got some active data to be aggregated, just let it go, tell it ready to aggregate. So there's kind of this auto oscillation that's occurring back and forth in this flow. It's like, okay, now I'm hooked. On this kind of a micro-streaming, event-driven type of approach for building applications, because this really kind of solved the problem in a much different way that I never would have dreamed of solving in the ways I've done it in the past. So that's it. So the subtraction layer is kind of this frictionless abstraction layer. It abstracts away databases, brokers, and message brokers, Kubernetes, ops. There's very little ops involved here. Services, like all kinds of different cloud services that are typically used, that we have to learn how to use, configure, set up, all these things. And then it's serverless. It's also serverless, by the way, without any cold starts. If you've done any kind of serverless stuff, cold starts seem to be the bane of the existence of many serverless types of applications. This is not, doesn't have cold starts as a feature. So it's really, this is what I meant by, is it finally time for the end of the data ice age, where we don't think, like when I'm building these systems, I'm not thinking about the persistence layer anymore. I'm just thinking about what my data looks like in the compute space. And I'm just dealing with things in the compute space. So my head is completely kind of wrapped around that aspect of it and blissfully ignorant of everything else. So when you build this thing, you build it, you deploy it, it deploys in a couple minutes, and that app I just showed you had like 18 views, 7 entities, about 10 actions, all kinds of data structures have to get set up, and Kubernetes has to be configured and all that type of stuff. And I just build this thing into a Docker image and deploy that, and the abstraction layer takes care of the rest. And I'll wrap up with this quote, because he's one of my favorite authors, Arthur C. Clarke, 2001, all that good stuff. But any sufficiently advanced technology is indistinguishable from magic. This is a big problem for us in our industry, because even though we're advanced, we're IT, but it's like we're still doing stuff that we've been doing for decades. Why? Why do we keep doing that? We've got to build on top of these newer things. And every time I've looked at something that felt like magic and I didn't go after it, and then later on I did, and I was kicking myself, I stopped. I deliberately tried to stop doing that. And I think this is going to be the fun part of what I've been talking about, which is called Kalix. We just announced it a few weeks ago. This is a platform as a service that's provided by Lightbend that gives us this abstraction layer. But we're not the only ones doing this. There's Dapper, and Microsoft is doing Dapper, so this is a growing trend as a much higher level abstraction layers. So I think they may look like magic at first, but they're not. I mean, they feel like magic, but it's great magic. It's a lot of fun. So thanks a lot. And by the way, I'm going to be here. I'm from the US, you might guess. I'm going to be here into next week. If anybody wants to talk to me, would like to hear more about it, want to meet somewhere, something like that, I would be delighted to do that. I'd love to talk to you. So if you want to spend an hour, an afternoon, or something like that, digging into this in more detail, just contact me. Talk to me here, or DM me, say on Facebook, on Twitter or LinkedIn. Thanks a lot.